Alright, the spinner below is divided into 6 sections. There are 2 sections, each of the colors blue, green, and red. You decide to spin the spinner 20 times and record which color it lands on each time. The outcome of each trial is listed in the table below, where R means red, G means green, and B means blue. The experimental probability of spinning a red is blank. Next, you decide to increase the number of trials to when 200 trials are performed, the spinner stops on red 60 times. When 2,000 trials are performed, the spinner stops on red 662 times. When 20,000 trials are performed, the spinner stops on red 6,667 times. Using this information, you conclude that the theoretical probability that the spinner will land on red is blank. Okay, experimental comes from the actual experiment that you run. So, how many red are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the experimental probability of a red is equal to 11 out of our total 20. So blank 1 would be 11 out of 20. Blank 2, theoretical probability, we come closer and closer to the larger and larger the number of trials we have. So I'm going to take the largest number of trials, so our theoretical probability of red is going to equal, the largest number of trials is 20,000, so something out of 20,000. Then we have 6,667. Using this information, well, I want to see what that is close to. So I want to know what the decimal form of 6,667 out of 20,000 is, not the long division. So I typed in decimal of that, and again it shows me, we can click here to show the steps if you would like to look through by long division. The decimal is 0.33%, which is, if we have our options, we could type in, so remember that it's 0.33. I'm just going to write that right here so I can remember it. 0.333. And then it's giving us our options. Now if I don't remember that 1/3 is close, is 0.333, then I would just type in decimal 1 divided by 3, and notice it's 0.333 ... repeating. So blank 2, the theoretical probability is 1/3.